YouTube channel at ncert.digital. You are watching YouTube channel at ncert.digital. Page 23, Class 10 Science. The bulb will start glowing in the case of acids, as shown in Figure 2.3. But you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the acidic solution by ions. Acids contain H ion as cation and anion, such as Cl in HCl, NO3 in HNO3, SO2 in H2SO4, CH3COO in CH3COOH. Since the cation present in acids is H, this suggests that acids produce hydrogen ions, HAQ, in solution, which are responsible for their acidic properties. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc. What can you conclude from the results of this activity? 2.2.1 What happens to an acid or a base in a water solution? Do acids produce ions only in aqueous solution? Let us test this. Activity 2.9. Take about 1 g solid NaCl in a clean and dry test tube and set up the apparatus as shown in Figure 2.4. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of 1. Dry HCl gas, 2. HCl solution? Figure 2.4 Preparation of HCl gas. Note to teachers: if the climate is very humid, you will have to pass the gas produced through a guard tube, drying tube, containing calcium chloride to dry the gas. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H ion from HCl molecules cannot occur in the absence of water. HCl H2OH3OCl. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus hydrogen ions must always be shown as HAQ, or hydronium ion, H3O. HH2OH3O. We have seen that acids give H3O or HAQ ion in water. Let us see what happens when a base is dissolved in water. NaOH is HO2 Na, AQ, OH, AQ. Page 24. KOH is HO2 MgOH2, S, HO2K, AQ, OH, AQ, Mg2, AQ, 2OH, AQ. Bases generate hydroxide, OH, ions in water. Bases which are soluble in water are called alkalis. Do you know? All bases do not dissolve in water. An alkali is a base that dissolves in water. They are soapy to touch, bitter and corrosive. Never taste or touch them as they may cause harm. Which of the bases in the table 2.1 are alkalis? Now, as we have identified that all acids generate HAQ, and all bases generate OH, AQ, we can view the neutralization reaction as follows. Acid-base salt water. HXMOMXHO. HAQ, OH, AQ, H2O, L. Let us see what is involved when water is mixed with an acid or a base. Figure 2.5 warning sign displayed on containers containing concentrated acids and bases. Activity 2.10. Take 10 milliliters water in a beaker. Add a few drops of concentrated H2SO4 to it and swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations. The process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. Look out for the warning sign, shown in figure 2.5, on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in decrease in the concentration of ions, H3O/OH, per unit volume. Such a process is called dilution and the acid or the base is said to be dilute.